Good afternoon, everyone. Welcome to MFG206. Digital transformation is not always easy, and access to data is one of the most important things which make the difference. In today's session, we'll talk about how to bridge the data between cloud and edge and make it easy to enable the transformation journey. We'll share our learnings. We have learned with a lot of our customers and partners. And my name is Pradeep Kaushik, and I'm product manager in industrial service team. And joining me today is Brian from Rehrig, and he'll also share how they kind of like tackle this challenge and make this process more seamless. The digital transformation is reshaping how business is conducted in manufacturing function. The overarching trend we are seeing is the data is kind of like part of every evolving process, and the amount and volume of data being generated is quite large. Whether it's an engineering and design function, smart factory, or smart product services, each one of them had their own value journey which can be achieved with the information and the data in those processes. Taking an example of small factory, the amount of data generated is used, but most of it is not used properly. If not, the value journey doesn't start. The good example of smart factory could be where we are looking at the machine information, could be availability, could be downtime. When it's available, it can help you generate more insights to make the process more optimized. Same in the case of smart products and services. The challenges are in the similar line. How do we improve this life cycle management for the machines which have been sold, or how do we improve the SLAs we can provide to the end user? And in the engineering and design, the number of product customers are dealing with, the variations which are coming up are humongous. And how do we make the design process iterative, which takes care of what my current state of operations are, my machines are, the constraints are. All of them really are important part of digital transformation journey, and they are very crucial now. One of the key things we learned with our experience working with different customers is the fact that the journey starts at foundation level with the data, but the value accelerate as you start linking different workflows to the data you capture. When we talk about smart factory as an example, as simple as connecting your asset to an application which can monitor your performance, availability, help you understand what is the availability of your equipment. By integrating it with functions like anomaly detections and maybe some predictive, you have an opportunity to kind of like start looking at not just OE as a metrics, but trying to actually improve it. And as you start working on improving those functions, you have an opportunity to improve your quality and yield. And that's how you kind of like turn the value flywheel in the smart factory use case. Similar to that in the smart product, as we talked in the prior slide, the value journey just accelerate with the data become available, improving lifecycle management for the machines which has been sold, improving the security and vulnerability assessment as the dynamic things keep changing. You can make that overall leading to better loyalty and customer satisfaction. Overall, the value journey improves and you get more gains out of it. Same in the engineering and design phase as well. Now, the interesting part is it does not just limit to those specific function, right? The key part is this value journey just magnify when you start looking these functions in an integrated fashion, which is kind of like the true foundation of digital transformation, where the effort and the investment we have made in the smart factory to make asset more optimized, the quality more improved, actually facilitate more value for you in the product strategy. So if you're a machine builder, your machine building process can be optimized based on the improvement you have observed and the data you have observed from your assets which are actually sold. Now, all of those information can help in the design improvement process too. So if you are working in large number of SKUs, and based on those SKUs, you have a need to build a new variation, you can look at the constraints you have in your manufacturing facility to kind of like optimize the design to meet the constraints of your process and let the value accelerate further. And that's kind of like is the flywheel is what a digital transformation can enable. But why does it matter? Every interaction in today's operational system, whether we talk about PLCs talking to the machine and equipment, or it could be humans interacting with HMIs, all of them are generating data, large amount of data. As per the IDC research, in the current time, every hour, the amount of data getting generated is nearly as much as how it was for the whole year, 20 years back. That's a lot of data. But unfortunately, a large portion of data is unused. Like 68% of data is kind of like not even tapped. It's captured and it's discarded. Even with those 68% data which is captured, for the remaining, for that data also, it's very hard to take advantage of all of it unless you have an integrated operation processor. So you lose value of those information. Now, why it's important? It's important because this helped you accelerate your transformation. It helped you create more value for your operations and processes. As per the research from Forrester, the operations, the companies who are working using insights driven from data are gaining 8.5 times more, are more likely to improve their revenue projection, right? And that's kind of like a big opportunity area. And this is something a lot of our customers are willing to tap into and in a progressive way. But the first step in building the data-driven strategy is actually collecting the data, organizing the data. A lot of those things come in. It feels like very simple, but it's actually not very simple. And we, based on our interaction with large number of customers in the last 5-6 years, we have kind of like found a few set of challenges which kind of like keep reoccurring. And these challenges may not happen in just one specific use case. Like if you're monitoring just one asset, it might look simple to integrate with one asset, but once you scale it to multiple assets, it can be more challenging. So we kind of like look at it, what is the end state? And from that end state looking backward, these are kind of like 5 key challenges, starting with the data integration, which is kind of like the first friction point. In the data transformation journey, the first speed bump comes in when you actually have to integrate your devices. The hardware in the facilities, the automation which exists for the last few decades is kind of called legacy today, but it was modern at that time. But the way technologies are changing, it has become very hard to capture in the latest technology stack. There are a lot of protocols. There are a lot of different types of secondary sensors. You can also look at data in different format. There are machines which still maintain data in files, right? And all of that makes the data integration difficult. It even become more difficult when you're dealing with varieties of assets, not just one asset class. How do you have a system which can support different varieties of asset classes needing different protocols, different types of secondary sensor? In addition, real-time decision making is also important, where you want to use the data, transform it into some information and give it back to the user who can take advantage of that, but not as an analysis and retrospect, but something they can take an action right away with that. And that needs some intelligence at the edge, also at the cloud, but the whole life cycle has to complete. That's another important challenge area. Data context is kind of like a little underrated, but it eventually becomes one of the big problem area, because the data doesn't become information unless it has the right context, right? And information is not just the asset hierarchy, where is my asset inside the plant? It's the relationship. What happens if this asset fail? What bottleneck does it create? What is the feed forward and feed backward scenario in case of constraints like this? And all of those things are sometimes not easy to model, and that needs special type of data contextualization need, which again is more than integration, but very important. Operation as edge, as we talk about, is so crucial in many use cases, and in many hybrid use cases, it's a combination of what you can do at edge and on the cloud. And at last and not the least, scaling becomes a very big problem, and that kind of like result into a lot of pilot project staying in the pilot forever, because they work very well for maybe one asset or one asset class. But the moment you want to take this to another asset class or a variation of it, it feels like it's a lot of rework, and that basically create a pause in the pilot which was supposed to roll out. And how can you deal with more of the same and the variation you can expect to see in the same without having to go back and kind of like break the purgatory you get into? For all these challenges, are key, but how do we define a model industrial data strategy? And when we look at it, it's not just about how the data is collected and organized, but to think about it in a way, the modern industrial data strategy make the data and the information you're able to capture interoperable for different applications and the use case you want to use it into. So if you have an asset monitoring use case, tomorrow you want to build a predictive maintenance use case, can I reuse the effort which I have made? And that is what the modern industrial data strategy want to empower you with, where the effort you have put in collection, organization, make it transparent for applications which need to use those data. And they don't have to care about what protocol they came from, what shape and forms they were in. They can look at it in a way where they can create those value versus one by one multi-point integration scenarios. Looking at these challenges of our customer in transformation at the AWS level, we especially focused on the first stage. How do we make the data collection, organization, and analytics more simpler? And this is where AWS IoT Sitewise is one of our premium industrial service that focus on kind of like making it easy to collect the data from different types of protocol. With our partner ecosystem, we support hundreds of protocol, thousands of secondary sensors which can be easily brought in. And once the data is brought in, there is a mechanism to organize them in hierarchies and relationship. You can create contextual relationship which goes beyond the ISA 95 models and structures which are more rigid. But after that, making it easy to also present that information to your users in a way you would prefer, directly in the system or through other, and as well as making it easy to integrate with some other analytics functions. So we don't believe that all these capability will get done in a single platform, but we want to make sure as a right data strategy, you have the right data foundation where all those capability can be enabled. Now, it all starts by connecting your assets. And as we talked about, that is the first speed bump in the process. Now, we have put a special attention on making that process simple. And this is truly the first step in bridging the gap between cloud to enterprise, making enterprise application, intelligent application at the business process level, take true advantage of all the data which is being collected on the edge, but currently not being usable. And in this case, whether we talk about machine connectivity, which depends on large number of PLCs, HMIs, protocols, Modbus, ControlNet, Profibus, UPC as well, none of them in single is enough. And this is where we work with the partners like Belden, Litmus, EasyEdge to kind of like bring a big support for protocols on one side, a large variety, but also secondary sensors. So if it's an IO-Link sensor, which is not even a PLC today, you can bring all of them into the data orchestration and kind of like work on it. Including the smart machine, if the machines are already smart, they are designed to be cloud connected, then very quickly you can bring the MQTT-based information into the cloud as well. So we kind of like support all those models. And this is where I want to bring in Brian. And Brian comes from, he's one of our light partner and customer who has used the same data strategy to mitigate the challenge of how to make it simple and scalable. So Brian.
Thanks, Pradeep. As he mentioned, my name is Brian Rowe. I'm the Vice President of IT for Rehrig Pacific Company. I have responsibility for all of IT. I also oversee cybersecurity and am responsible for shepherding the organization through digital transformation. Now, a thing that you get used to as an employee of a company that's not a consumer brand is the first time you tell somebody who you work for, they go, wait, what, who, how do you pronounce that? So I thought it would be good to take maybe just a quick minute to show you a video that came from my friends in my marketing team to kind of give you a glimpse of who Rehrig Pacific is and what we do before we talk about what we did in our connected journey with our factories.
Rehrig Pacific is a company of innovators, people who imagine the world as it could be and make things that will get us there.
Cruising at 90, yeah, me and my crew. Nothing can stop us, we do what we do. 1000% and we getting it done.
Our logistics solution business is strengthening the supply chain and waste industry by providing sustainable innovations that help our partners create closed-loop systems. Our delivery solutions business is revolutionizing direct store delivery from the warehouse to store shelves through groundbreaking material handling and technological solutions. We are mindful manufacturers with 8 plants across North America, dedicated to finding new ways to use hard-to-recycle plastics. We're designers and engineers who are rethinking the way systems work together, creating integrated product ecosystems that add real value to the industries they will one day live in. We are best-in-class service providers focused on enhancing the customer experience for our partners as a valued extension of their teams.
1000%, but we getting better.
We're always looking inward to build a stronger, more inclusive company where more perspectives yield better results. Because in the end, building a better business from the inside out ultimately means building a better way of life for each other.
1000%, but we getting better.
Rehrig Pacific is a family that celebrates our people and empowers them to create innovative solutions that effectively and responsibly move goods, resources, and ideas.
1000%.
We are Rehrig Pacific.
Getting better.
And so really, at our core, we are a 111-year-old family-owned manufacturing company that is producing containers that have been used to drive efficiency into the supply chain for our entire history. In the last 15 to 20 years, we've also become a technology provider. We build SaaS applications. We also deliver material handling solutions that help our customers move their plastic containers around in their supply chain. And as a component of that, we spend a lot of time acting as a trusted advisor with our customers, trying to help them identify where their pain points are, where the elements in their processes have opportunity to be optimized through the use of advanced technology, through the use of data-driven decision-making. And a few years ago, we stepped back and had a conversation internally and honestly had an honest moment of self-reflection, which is, are we bringing that same level of criticality, that same sense of being a trusted advisor and looking for optimization into our business operations? And a component of that started with asking questions about what would it take for Rehrig to step firmly into the digital age ourselves. Many of our customers are changing in terms of their expectations of us as a manufacturer. We looked at and said if we could deliver anything for our customers, it was improving quality, improving the flexibility of our manufacturing so that we are more nimble, we're more agile, and we can respond faster as they have needs. And that meant that we had to think very differently about our manufacturing operation. Now, you saw a number of the types of containers that we produce, and the core, the biggest component of our revenue portfolio is producing plastic. So we put together a core team between myself in IT, and then I have a peer inside our transformation organization who oversees advanced manufacturing. And then we brought in a couple of key stakeholders from operations and started to take a critical look alongside AWS and one of our partners, Slalom, to understand where were we and what was it that we were going to have to take a look at. Now, interestingly, and I took to calling us one of the brownest fields that I could find, and there were three big observations that popped out. And of those three, I think if in retrospect, all of them were relatively obvious, but we hadn't taken the time to sit down and put them on paper and recognize that they were challenges that needed to be addressed. The first of those was that we had lots of smart things sitting on the floor. I mean, through the labor shortage years of 2018 and following, we'd had to invest in cobots to do work that we couldn't find frontline staff to do. So we had lots of advanced pieces of technology, but it was all sitting, operating in isolation. Now, as a company security officer, I was actually grateful for that because many of those things were unpatched, highly vulnerable, sitting on the floor, and they were at least isolated unto themselves. But that represented a real problem. That meant that anytime we were making a change, we were doing it all manually, and we had to touch many, many things within the environment to affect a change in a work center. The second thing was that we frankly had a lot of legacy technology. And on the surface, we're an old company, and so that kind of makes sense, but it took a moment to realize that our oldest manufacturing facility had been in constant operation for 52 years, and our most recent facility is only 3 months old. And you can imagine what that means in terms of the generations of capabilities and machinery that we found as we started really looking deeply at the problem. And then the last piece was that we really thought hard about the fact that as a manufacturing company, we don't produce automobiles that are relatively high profit margin per unit, right? We don't produce microchips that are, again, relatively high profit. So we had to start thinking about solutions that would give us flexibility, that would scale as we had real value-based use cases, that wouldn't require that we rip and replace massive amounts of equipment within our factories, because frankly, we couldn't afford to do that. So we settled to a pretty firm scope that represented 76 work centers, and for us a work center includes at least one injection molding machine and the ancillary equipment required to decorate, assemble, and palletize the product. We identified across our 7 major facilities that we had 5 complete generations of injection molding machines that were mostly from 2 vendors. We had 125 robots in the environment. I think that was actually a shocking number when we finally sat down and started to count, and somebody went, wait, how do we have over 100? Because they had accreted 1Z, 2Z over time, and suddenly we've got a whole fleet of robots. We had 7 hot plate welders, which if you're not familiar with injection molding, this one might be new, but we produce a lot of plastic pallets, and in order to get structural integrity, they're actually molded in 2 parts, a top and a base, and then they're put into a hot plate welder and welded together to get the structural rigidity that we need for the life of that pallet. We found that we had 10 distinct material blender systems. So the tools that were bringing raw materials to the injection molding machines actually outnumbered the number of facilities that we were operating in. We also found that we had about 300 PLCs, and a quick survey of the brands reflected that there were at least 7 logos out there, some of which were no longer in business. And some of those PLCs had literally been sitting on the floor operating for almost 20 years. And so as we started to scope out the problem and started to think about how many protocols do we have to support, how many things do we actually have to touch and reconfigure, what is going to help us solve this problem and generate enough flexibility that we could meaningfully connect our factory to become a data-driven manufacturing operation without having to completely undo all of this. After a lot of soul searching, we came back to a premise that was foundationally based on these 3 tenets. And the first of them was that we needed a comprehensive framework. And I will summarize this by saying that our aim was to minimize the number of things that were sitting at the edge that would talk to the maximum number of things sitting on the floor that would allow us native cloud connectivity to get that data contextualized, digitized, and parked in a data lake. The second one, and very much because I am the security guy at the organization, but we knew that data and network security had to be at the heart of any solution that we deployed. We're going to take all of these things, some of which are highly vulnerable, in some cases by the design of the manufacturer, to be vulnerable. So I've got to allow for things like microsegmentation, which is not well supported by most OT vendors. Right? We had to think about things like there's no role-based access control, there's no multi-factor authentication, there's none of these core capabilities that exist within these technologies. And yet we need to be able to securely connect these things, not put the rest of the organization at dramatic risk, and ensure that our data was secured from edge to cloud so that it could be used, and that none of the things that might be classified as secret sauce in terms of our manufacturing process had an opportunity to leave the organization. And lastly, and perhaps most importantly, we wanted to maintain a high degree of what I will call data freedom. And if for some reason you're sitting here and you work for an OT vendor, you might have to take what I'm about to say graciously. But at the end of the day, if you were to survey the 25 to 30 suppliers that we use, I'll pretty well guarantee you that every single one of them has some kind of connectivity solution. And it works great if everything in your factory has their logo on it. But if we did that, we'd continue to perpetuate these silos. We'd just move them off the floor and put them in the cloud, and it would still be siloed, and we'd still have to do all the processing. And so our goal there was to find a solution that would allow us to not recreate those silos, but rather to have a brand agnostic, protocol agnostic set of solutions sitting at the edge that would pull the data, get it contextualized and pushed into one place, and then that one place would become our clearinghouse, whether that was northbound data to enterprise systems like our ERP or our MES, or to other AWS services in this case, like Managed Grafana, that would allow us to rapidly solve use cases that weren't already accounted for in some of those enterprise systems. So, and I'll tell you, I did not bring a technical version of this diagram. If you want to get into the weeds of how we did this, I'm happy to hang out for a little bit after. So this is kind of the broad strokes, and working from the left, that's actual physical things sitting on the floor. So we decided that we were going to start with our injection molding machines. And on the one hand, that was a complicated decision because there's enough variance in what's there that it took us a fair amount of time and discovery work to recognize where we could find a spot that was a little bit of the sweet spot. And we settled by leveraging Euromap 63, which is an older version of a protocol, but it happened to manage more of the fleet than any other individual protocol. And so from that, we were able to connect most of our fleet in one way with one set of tag templates and with one technology. We then moved into PLCs and robots, started pulling that data in via OPC-UA and in some cases MQTT. And so that to me is kind of our tier of devices that have a fair amount of native intelligence or native connectivity. And all of those things are connected through Belden's Horizon Data Operations platform. Now, in the lower tier category of things is where we know we're having to augment. The device that we're touching or the system that we're touching doesn't have native intelligence, and so we need to add that intelligence. And there's two major use cases that we're doing there, and I've separated them because they are using different protocols. As a manufacturer, as many of you I'm sure are, we're looking for constant ways to hit our sustainability goals and try to drive more efficiency. And so we've started a program monitoring power utilization, leveraging sensors that are Modbus TCP, that are connecting to CloudRail, and then all of the rest of our secondary sensing structure is based on IO-Link. Many of which have been that is the one place we've done rip and replace. We've had folks walking through facilities, unplugging, unwinding pressure and temperature sensors that were purely analog that we very literally had to pay somebody to walk around and stare at 3 or 4 times a day with a digital version of that sensor that then plugs into CloudRail. So both of those tools then have native integrations with IoT Sitewise. And so all of our data lands in one place. It's contextualized within a namespace in a hierarchy that is human readable, that any of my OT engineers can come in and they're looking for a particular data element. They know how to find it. They can see it. Now, you can see, as I mentioned, the very first thing that we did was leverage the native integration with Managed Grafana and start building some near real-time observability for those engineers. That required it's not fair to say it required no effort, but by comparison, it didn't require much effort to get it working. And for them to start getting self-sufficient at identifying how to connect that data into a visualization that would then result in them having the ability to set up alerting and actually get real-time observability of that asset. We've then started to cross-deck that information to our MES as opposed to having a separate historian. Part of the challenge that we were trying to address there is, I wanted to have the minimal number of things sitting at the edge. And frankly, we also needed things that supported high availability. As we started looking at solutions that would do that edge processing, we honestly ran into a lot of challenges when we started talking about things like, hey, I need to deploy this on OpenShift in a container, and it needs to be portable. And fortunately, our friends at Belden were like, that's great, we have a container version for this, and we know exactly how to do that. We designed it that way. That was a little bit of a rarity in this case. We also have built a data infrastructure that is pulling sampled data off into Redshift so that we have a consistent growing lake of data for deeper analytics. We're not keeping every bit of data there, but it's created flexibility for us to stand and say, okay, we know what we're getting. We have the ability to change that, whether we need to keep more data or we need to add metrics to it. But right now, we're at a stage where we only have a handful of our factories lit up. They're not all done. And some of the expertise to identify what data do we need and how meaningful and valuable is it going to be doesn't exist yet. So we're building that process into our human capital plans right now. So every bit of this is live in several of our facilities. We have our flagship facility in our Kansas plant is actually 100% lit up. Every piece of their equipment that is relevant for our core use cases is already online. In fact, I didn't bring a live version because I figured it would be a little bit like watching paint dry, but this is a quick snapshot of one of the dashboards. And by the way, this dashboard didn't come out of IT, it didn't come from a partner. The operations team built this. And so they sat and had a conversation about between reliability and maintenance and the production supervisors, what would be meaningful? What process parameters did they need to be able to see? How did they want to represent it? And one of the things that I, as an IT leader, spend time talking with my staff about is that IT has honestly learned a lot from manufacturing in the last 20 years. I don't know how many of you have read the Phoenix Project. Probably more than one of you, right? And if you haven't, effectively it's an allegory of teaching an IT team to think about their work like a factory thinks about its work, identifying bottlenecks, looking to shift left, building efficiency into the process. And one of the things that we've talked about with our operations friends is this is IT actually bringing something that IT is pretty good at, near real-time observability. There's like 9 vendors on the expo floor. This is all they do. That hard disk is about to fill up, so I'm going to send somebody a note and it's going to generate a ticket and it's going to get Johnny out of bed to go fix it at 2 a.m. our manufacturing friends don't have that, but now we're getting that capability to them. That was a thing that they saw as immediately valuable. They're also starting to deliver opportunities where the production supervisors used to have to walk around and look at the individual HMIs and understand, when we started up this work order, did we actually put in the right process parameters? Is the cycle time right? Are we getting the right mix of material? And they no longer have to ask some of those questions, because now the alert thresholds are being set dynamically based on that information. So if they don't get an alert, it was done right. And if they get an alert, they know exactly what needs to get addressed, and they're getting it quickly. So as we think about what's next for Rehrig, and maybe talk about some of the other things that we've achieved, that process parameter control piece that I just mentioned has already made an impact to our overall product quality. You know, things that sometimes we don't think about. I learned very strange things. I knew nothing about manufacturing, plastics manufacturing, before I took this role 7 years ago. But it turns out that if we take a 95-gallon rollout cart mold and we extend the cycle time, you get a 96-gallon rollout cart. Who knew? To me, it's like a mold, it's the same size no matter what you do, but that's actually not true. And so things like that, understanding how is the cycle time, because that can put a product out of spec. And when some of our customers have high demands because their plastic containers go into their own automations, being out of spec can create real problems for that customer when the product arrives. The next three things, though, are things that we're either toying with in the lab or starting to develop plans around. So as I mentioned, we are building a data lake, and we've started some basic work on thinking about things like line comparison. If I have work centers that are running the same set of products in different facilities, now I have enough data that I can set them side by side and understand, where are they different? What process parameters are different? How is the output and the throughput different? And in some cases, how even is the power usage different? Lots of capabilities that before we didn't have enough data. It was done, the engineers would sit and chat over a beer, like anecdotally, like, oh, I think it might be this, or I think it might be that. And now they're driving those conversations from data that's sitting in our data lake. We're also evaluating lots of opportunities for predictive maintenance and reliability. If you can imagine, these injection molding machines have lots of major hydraulic systems in them. And I don't know if you've ever seen a pump catastrophically fail, but when your machine is like the size of a semi, and there's hydraulic fluid running all over it, when you have an impeller that comes apart, you spend days refiltering all of that material to get all the little brass pieces of that impeller out. And so now we're leveraging this same data infrastructure to get vibration data that we're putting through a POC to see if we can do advanced vibration analysis to prevent that catastrophic failure. It's a 2-hour PM if we know what's going to happen. If we let it fail catastrophically, it takes 4 days, assuming we have the part. And so that's a real return just on the basis of having the data available and being able to hand that data off, in this case, to a third party for analysis. We're also now prototyping digital work cell orchestration. Pradeep made a comment about the cost of changeovers. So one of the things that we've identified is that now that we're starting to get through some of this data, we've actually opened up the thinking of our plant engineers. They had been living in a box where things had to be analog, and they didn't have access to enterprise data sources, and they didn't have the ability to look at things digitally and analyze them digitally. And so now we've taken a microservice that my team wrote that sits in AWS that was already extracting work order data from our ERP system. And in our lab, we haven't actually put this into production yet, but in our lab, we now have that data pushing to MQTT so that our PLC programs can access that information. So a good example of that, we produce tons of rollout carts or trash cans, and those work centers don't produce the same. I mean, every work order could be different in terms of color or branding. And so this gives us the opportunity to, with a fully automated system, have the PLC ask the question, what work order am I running and what color should it be? And now there's a laser color sensor sitting there going, is it the right color? Is it in spec? And they couldn't even do that before. And so I think a key element that I don't know that we expected, we hoped for but didn't necessarily expect, is that by connecting our factory elements and putting those, empowering our plant engineering teams to think about this through a digital lens, they're starting to find new and innovative ways to standardize and reshape their process on the shop floor. So, really appreciate your time this afternoon. I'm going to hand it back to Pradeep to finish up the conversation.
Thank you, Brian, for sharing your experience. I really find it interesting how they thought about the whole architecture in the beginning. thought about how they need to deal with different varieties of data protocols upfront, and made an architecture which kind of like will work for them in future too, as they deal with new asset classes, and will be smooth. Now, then what, like once we have collected the data, does that mean we are digital? Looking at the market research and the feedback from our customers, we have kind of like noted that nearly 70% of the customer we have been talking to or interacted with have already started some steps in the digital transformation journey, or are very soon going to. They are in the process of putting the plans out within a year like that. And that's a good sign, which means that there is a strong recognition of the fact that digital transformation is important. We also noticed the customer who have kind of like started already those journey, around 30% of them only feel satisfied with the desire they had when they started the journey and what they have been able to accomplish it in some time. And we also noted nearly 40% of those customers are kind of like feeling stuck in a way where they started in the process. They feel like that doesn't deliver them the right value, and they're going back from one POC to another and to another. And when we think about it, this is where the digital transformation overall is more than just being able to collect the data and store the data. There are more other aspects when they start to come in that can kind of like bring a risk to the whole transformation process and pull you back from where you want it to be. And now you're looking at re-architecting the whole system again. This is where the important question come in, and the question we must answer as we start the journey. What does digital mean, right? And digital doesn't mean that I have all the data. Digital doesn't mean that I can compute them, transform them, do analytics on them. But the digital in true sense, which is actually the enabler for value enhancement journey, the flywheel we talked about, is when the data is in a shape and form and size, it's interoperable in a way where it can help you make decisions, a data-driven decision. It's available across the globe. When you move from one location to another location, you can quickly take those outcomes and bring them up. It has global connectivity. It is very cognizant of the need of cybersecurity and evolving threats, so you cannot do it after a fact. It also need to ensure that it's sustainable. You're not repivoting the whole architecture for every place you scale. Every factory become a new deployment in itself, with the whole stack in itself. And as well as it need to have a human-centric approach. How do we make the data available to a user in a way they can interact with, can benefit from it, and actually can get some skills improvement done as well. So when we think of digital, when we see and talk to our customer and we try to together think of digital, we think of a fabric which can actually help in all those functions. And those are important for them to achieve what we call it as a desired value in the short term, mid term, and long term. Now, another way to look at it is the terms of the digital maturity. It's kind of like more simpler than the last one. But if you think here, a lot of customer today believe, based on the maturity they desire to be in, that they are still in the traditional manufacturing stage of maturity, where there are silos of equipments, processes, there are sub-assembly lines, there are machines. They're smart in themselves. I mean, they have HMIs and all connected, but they're not able to connect with each other and kind of like accelerate the joint synergized value creation. Now, when they start thinking about bringing it together, connecting them in a workflow, and then kind of like working on building more integrated use cases, let's talk about like asset visibility, not on the asset, but across a line, across the whole facility, and being able to look at optimization at that level, then they're kind of like leaning closer to the idea of connected manufacturing, where different aspects of manufacturing, different functions in manufacturing can kind of like take advantage of the information each one of them is generating in real time, and are able to react to it as well. So if I in a process we realize there is a bottleneck, the risk of bottleneck in a part of the process is high, how can I have the subsequent process take knowledge of that, and if possible start with the mitigation process and make that whole life cycle closed loop, so it's not manually driven. And that kind of like is more unconnected. But the moment we take the vision even up and think of it like a proper software driven automation, where the majority of your processes are kind of like interconnected in a data fabric layer with workflows which are mostly automated. You're not looking at humans at every step, but they are largely functional. But taking it further which is a North Star to the light out automation, is when you literally don't need any human. And I would call it's a good vision to have, but that should not be the starting point target. If you're starting the journey, you categorize yourself still in the traditional, getting connected and being at a point where different assets, equipment can correlate with each other is a good step up for the scenario. Now, as we talked about, a successful digital transformation is more than data. We also talked about how in our own platform, IoT site-wise, we make it easy to collect industrial data, support different protocols, help you organize the data in a way that you can use it for different functions like analytics and all. But to make the digital journey truly possible, we need to cover the other aspects as well, like cybersecurity related. How do we make analytics easily accessible to those data points and the user? We also want to make sure how different partners and the systems customers have, maybe ERPs, different MES, can also be part of the same data fabric and in some way. And this is where at the AWS level, we think of it as a broader architecture vision, where there are different components and services which are available. You don't have to start with them, but they're available when you feel the need. And that is the whole idea of getting away from the pilot purgatory, because you know that in a broader architecture, you can start very simple. Maybe if you have an asset monitoring use case, it's as good as starting with IoT site-wise, collecting variety of assets, putting it into an organized data and start to visualize it. The day you feel the need of, oh, I also want to add maybe for a few assets predictive maintenance, and I have a specialized team which build my machine learning model, I want to make sure that all the effort you have done is reusable. You can just connect that ML model using the SageMaker service and make it part of a workflow which site-wise can take it back, and now you can connect it back to the same application dashboard where you were doing the asset monitoring functionality as well. In addition to that, if you want to integrate GenAI, GenAI is something where you want to enable some of those capabilities. There are paths to that as well. But the idea of it looking at digital transformation as a journey, which you will start with specific use cases, progressively add functionality, but you are in an ecosystem which allow you to add it when you need it and does not need you to go back and think about it, what next, and now it's another POC, is very crucial. And this is kind of like one of the key learning we have with our relationship with customers, and we share with our customer again and again. Now, when we talk about this big architecture I showed you in the prior slide, I also want to mention, it can be sometimes overwhelming to things like, oh my God, I need all of this and this is too much. Where is one single platform? And I always suggest, right, it's always good to anchor your strategy on certain use cases. And it could be very simple use case to start with. It's not what you complete. It's all about how you complete it, how you deliver it. So asset monitoring is a very simple use case. It pivots on the idea of connecting your asset. Maybe you have one machine, you're connecting with OPC, nice. The data come in, you have all organized, you have created hierarchy and knowledge, and you're visualizing it in a dashboard, cool. The moment you have another machine which does not support OPC, you're looking for Modbus, doesn't have a different latency requirement. You want to add more sensors, which are secondary sensors. The architecture should allow all of them coming in without you having to change the first workflow you created. And that's kind of like is the thinking process which comes in. Predictive maintenance is another important use cases. And I do see a lot of customers looking up in the value chain of how can I optimize my asset more than just monitor it, right? But being able to use the same asset monitoring infrastructure you put in, attaching it to an analytics workflow. Some of those are within the platform like SiteWise, but I would say there could be a lot more possibilities. And that is where being able to bring in the SageMaker model or maybe other partner model give you that scalability which you desire, which you need to achieve the transformation objectives. Enterprise level visibility is equally important. The facilities are not limited to one place. They can be global, and how do you look at them across the region? How do you compare them across the region, but still having the same infrastructure to work with? And that's kind of like is the line of thinking. If you start with enterprise visibility, that's a very good use case. But think back at the architecture which allow you to scale from enterprise visibility to predictive maintenance in future. And that will allow avoiding the cycle of pilot purgatory. Predictive quality is another one. And we see a lot of our customers are kind of like leaning into the area of how can I optimize my batch. And as a part of optimization, because the batch process can take a lot of time, it could be a couple of days to weeks, how can I actually predict quality based on the changes which are happening on the process? And that's a combination of sometimes simulation, and it could be also just basic machine learning analytics, but how do you kind of like bring in those physics-based model and allow a system to kind of like analyze based on my current state. If I do this, what if analysis, you want to integrate those workflow into the same architecture, making it work. So any one of them could be a starting point. Building it in a way that you can move to the next one is kind of like is the foundation of a scalable data platform vision. Now, this is not what we just think. This is not what we just preach. It came as an experience. We progressively added these components into the data platform architecture for us because we felt in different engagement, customer needed them, and it became something we want to talk about it upfront. Talking about Toyota, one of our premium customer, they started with the vision of how do I optimize my asset, right? And I want to reduce my downtime. And they started with that particular use case, but they took a thoughtful approach of building an architecture which allowed them to scale. But in the first success, they had a successful deployment of finding anomaly and making prediction on the risk of failure. And in the initial test, they were able to kind of like track 16 incidents, which resulted in saving 20 hours of downtime on $80,000 of kind of like saving in the test validation period itself. And that kind of like is the power that when you start building on this, you can test it fast. And once you test it on one, now they have actually scaled the same workflow to more than 100 assets already, and kind of like in a very short horizon. And that kind of like shows the power. While the assets are not exactly the same, assets need different type of data, they need different protocols, but now they were able to bring in that predictive maintenance capability across those asset class in the same architecture pattern very quickly. Frontmatic is another of our customer focused on machine. They build machines, right? And they think of it from the smart product strategy. How do I make the deployment faster, capable as I scale my machine from one customer to multiple, roll them out across different user bases. And they have been able to kind of like use the same architecture pattern to reduce the deployment time from hours to 15 minutes. And that is because it's so templatizable. Once you kind of like have an approach of protocol conversion is one layer, the data organization is another layer, the data transformation is another layer. The templatization makes the process so easy that when you bring in the new asset, which you haven't done today, then to bring that in, you're looking at 70 to 80% of commonalities to what you have already done and making minor changes. And that kind of like change the way you will scale as the asset changes. Yara is another very great customer, and they're in the field of crop, nutrients, and chemical processing. And they took a very thoughtful approach, and they started with, okay, let's do POC on this. And then kind of like it pivoted, and we kind of like talk about too, but they also spent some time and kind of like made a decision to think of it as a digital platform, production platform strategy, where they want to make sure this strategy is not limited to one use case, but can actually take advantage of all other use cases can be built on the same platform. So they have so far deployed 130,000 industrial assets in more than 100 plants using the same common fabric which is built on this architecture. And finally, I want to talk about Ara Steel, and they are a customer we are working as we talk, right? And they are a specialized steel manufacturer in Europe, and they, in their beginning of the journey, the desire to start with as simple as being able to monitor the furnaces, being able to optimize it, provide guidance to the associate as the furnace processes are evolving, and kind of like make the life of associate easy, make the performance of those assets easy, and kind of like scale it from there. They also said they are very interested in bringing the benefit of technologies like Gen AI to their associate. How can it help them in their day-to-day operation? And right there, we kind of like work with them, and very happy to announce we also launched a new feature in Sitewise that brings the generative AI-powered assistant natively in Sitewise. What it means that now Sitewise has a generative AI-powered assistant which can understand the asset model, understand the data inside the assets, all which you have collected, current and historical, can understand the relationship you have established as a part of organizing it, and can also connect to additional knowledge bases if you're willing to give access to the SOPs and the product manuals and the vendor manuals and even the emails and the knowledge bases which are of importance. Again, those are not replicated into our account, they stays where they are, but we are able to access them on demand based on the user question and kind of like give a user a way to interact with it. And this enables as simple as alarm summarization. You see an alarm, you click a button, and it tells you what is this alarm, why it happened, and what you should do next in one shot. And that saves a lot of time, and that's what Aristide liked about it. You can do situational analysis where you're not looking at just one property, you're looking at a combination, or let's say 3, and you're trying to see how all of them are correlating and causing a situation you are in currently, but it's all going through GenAI, doing it all together. This also allows you a natural language-based interaction. So if you have follow-up questions and you want to narrow down the scope of the focus, like only one aspect of this problem you want to look at, you have the opportunity to ask this question and narrow it down. And this kind of like take the journey one step further. But again, this works natively as soon as the data strategy is consistent. Now you don't have to put an effort in training the model. You don't have to put an effort in building the guardrails. You have this, now it's out of the box available. And Aristide is one of our launch customer for this. With this, I want to kind of recap and say that the digital transformation journey is truly rooted in the modern data strategy. It can start with the baby steps, but the thought process and the vision should be inclusive of what you would need next. And setting the right modern data strategy up front is a key differentiator of whether the risk of you becoming another POC, which need to go back, is high or low. And we have tested with many of our partners and customers who kind of like switched to us after some time based on that. The second thing I also want to mention, this whole transformation is a team sport. There is no single platform. I won't say Sitewise can do it. I won't say AWS can do it. I would say all of them a strong foundation and they get you ahead. They get you started well. But to make it successful, you would always need partners. We always have partners. We have partners like Siemens. We talked about Belden. We talked about Litmus. We have many other partners as well. And we believe the real success when the partnership we have, the partnership our customers have, we all come together in kind of like building the right foundation and integrating with all those functions comes in. And at last, digital transformation is an enabler for more value creation. You get into it and it kind of like work like a flywheel. More you connect it, more you participate in it, it kind of like create more value for you. With this, I would like to thank you all for coming in and I really appreciate your time. I know it's 4 o'clock, late evening, kind of like a meeting, but I appreciate coming in. And thank you, Brian, for kind of like coming in and sharing your wonderful experience and kind of like facing the challenge, but mitigating it, taking it heads on and solving it. Thank you.